Last thing we want to talk about is a midpoint before we do example number 4. What do you think that means?
It's in the middle.
Yeah. Well, it's a little more formal definition. Is a point that divides a segment into two congruent segments. Okay. Now we would say the midpoint is in the center and in the middle, but to be a little more formal, we start with a segment and then we divide that segment into two equal segments. That makes sense? That's what a midpoint is. Now, if we draw a line through it, well, first let's talk about that. So I'm gonna have this line or segment, okay, and we'll call this point here. Actually, I want a different color. We'll call this A. We'll call this B. Now, if I have a point here that is right smack dab in the middle, and I'm just eyeballing it. This point right here, actually, I want to be consistent with the notes in the book. They did it this way. This is A and C, and this is B. We would say that B is the midpoint of AC, and then remember the reason for that is because AB is congruent to BC. All right, that's how we define that B is the midpoint. Does that make sense? I guess we could even say something like this, that the measure from A to B is equal to the measure from B to C. All right? But now if I take and I draw a line through that point, and I label this, let's say, line L, then what we would call line L would be a segment bisector. Whenever we see the word bisector, just assume it's dividing it in half. So if I say an angle bisector, I start with a big angle and I say this is the angle bisector, what does that mean? I divided the angle into two congruent angles. We should probably be a little more formal. When I say that this is a segment bisector, I'm saying that line L, just to kind of be clear, line L is a segment bisector. Why a segment bisector? Because it's dividing the segment AC, actually let's write that, of AC. Because it's dividing the segment AC into two congruent parts, two congruent smaller segments. Does that make sense? All right, cool. So now watch this. Let's do example number 4, and we will call it a day. So for example number 4, oops. So for example number 4, we've got this line segment PQ. Oh, I did it again. PQR. And we're told that Q is, in fact, the midpoint of PR. And then we're also told that this is 6x minus 7, and the length from here to here is 5x minus, or I'm sorry, plus 1. And it says, hey, what's PQ? What's QR? And what is, oops, PR? Hey, that's not fun. So they're asking us to find the lengths of this. Now this is similar to the problem that we just finished, example number 3, but not really. At least with problem number 3, they gave us a distance. But because Q is the midpoint of PR, what do we know? Yes?
And PQ and QR are equal.
Yep. So we're going to say that PQ is equal to QR. Well, PQ, though, technically is 6x minus 7, and QR is technically 5x plus 1. Hey, you know what? That's not that bad. I have an equivalent statement with x's and numbers. I just need to get all the x's on one side and the stuff on the other, and then I can plug the x value back in. So let's try that. I'm going to add 7 to both sides. I get 6x is equal to 5x plus 8. I'm going to minus 5x from both sides. And I get x is equal to 8. Well, that's cool. So if I wanted to find PQ, I would say 6 times x, but we know that x is equal to 8. So 48 minus 7 is 41. Now over here, I would say 5 times x, which is 8, plus 1. 40 plus 1. Hey! Q really is the midpoint, and PQ is really equal to QR. Now what's PR? Yeah, it's the sum of the parts, which is 82.